In my last video, I shared the most tragic story of OceanGate's Titan submersible and briefly have touched upon the entire incident, including the flaws which might have caused this incident. But in this video today, let's try and understand what is the root cause because of which this entire catastrophe happened and because of which 5 known personalities lost their life. As we all know, Titan was a small diving vessel designed to explore the wreckage of Titan, which is at around 3,800 meters below the sea level. But let's understand how did this submersible and the system on it actually work. There are a lot of interesting systems on Titan, from propulsion to communication. Some that worked, but some that tragically didn't. And one that was even designed to dissolve underwater. Hi everyone, my name is Satyam Srivastava. I'm a management consultant by profession. I welcome you all to my YouTube channel, where we try to decipher complex technologies and issues into simpler bits. Let me start with giving you a quick overview. The Titan submersible was designed to go as far as 4,000 meters underwater, and it had to take the pressure in that deep water, which is equivalent to an elephant standing on one leg and then 226 other elephants climbing on that elephant, is the amount of pressure which it had to take when that submersible is that deep under the water. On top of this pressure, it also had to navigate through darkness, cold, and difficulty of communicating with the surface. These are the part of what makes the deep sea exploration too difficult. Titan weighed approximately 10 tons and was primarily made of few core components, the largest of which was carbon fiber, and the hull was made out of it, which was the eventual failure point of the vessel and sadly resulted in all those aboard losing their lives. The hull was 5 inches thick. Repeated exposure to high pressure meant that on the 7th dive to the Titanic, it imploded. To demonstrate this effect, here is a railroad tank imploding when put under a vacuum. This caused by the pressure outside being much larger than the pressure inside. The implosion of Titan would likely have been even quicker. This left me wondering what actually put in place to stop this happening. The first way to prevent failure like this is to create a virtual model of the submersible and test its limit. However, carbon fiber is notoriously hard to model because it's not a single block of material. It is instead lots of thin fibers that are interwoven and cured together. This also means there are many ways it can weaken as layers shift and come apart from one another. Without any destructive testing to fully test the limit of Titan, these models were just not enough. This is where the second system was meant to come in. Aboard the Titan was a real-time acoustic monitoring system which the OceanGate claimed could detect buckling of carbon fiber hull prior to a catastrophic failure. According to a patent held by OceanGate CEO Richard Stockton Rush, this uses multiple small sensors such as ultrasonic microphones and strain gauges to monitor vibration in the carbon fiber. This data would have been collected at regular interval and sent to a centralized system for storage and analysis. At this point, it should have been able to assess the health of internal and external structure and predict the failure condition. However, this type of testing is relatively new field and clearly wasn't enough in the hindsight. In fact, open letter from Marine Technology Society said they had concerns about the Titan design and it could result in catastrophic negative outcomes. Not only was the use of carbon fiber concerning, but so was the tubular shape, which is much worse than a sphere at distributing the pressure from weight of the ocean. Thirdly, we have end caps of Titan, which are made up of titanium and secured onto the main hull using 18 bolts, giving passenger no way to get out from inside. The viewing window was also reportedly made from a material that was only made to work until 1,300 meters, which is just a third of the depth of Titan wreckage. These components were all tested on 1/3 model in collaboration with University of Washington, at which point an ex-employee called David Lockridge expressed concern that the scale model of the sub had revealed flaws in the carbon fiber under pressure testing. But aside from the fatally designed hull, how did the Titan submersible actually operate or know where it was going? After an initial briefing, the first step of Titan launch was to deploy the docking station, from the main ship. This is why the Titan was actually classified as a submersible rather than a submarine, because a submarine is able to leave and come back to the port under its own power. The docking station would then fill up its ballast tanks with seawater, increasing its weight, causing it to plunge 9 meters underwater. At this point, the Titan could detach and begin its descent, whilst the docking station refill its tank were there and float to the surface. And at the end of the voyage, the process would then be done in reverse. The Titan was carefully balanced so it wouldn't float or sink unless the electric thruster were activated. It had 4 electric thrusters in total that could propel it up, down, forward and backward and rotate it around. And these were sourced from a company called Inner Space and specifically designed to operate extremely efficient in both forward and reverse direction. The power for these motors would then come from an onboard battery system similar to those found in the electric cars. The controls for the submersible have come under a significant scrutiny in the media, with the main focus being on the game controller used to direct the vessel. However, as strange as this sounds, it is actually quite common in military applications too. Due to their ease of use, durability and accessibility, game controllers are currently used all around the world to control anything from explosive disposal robots to Virginia-class attack submarines. The Titan also had a touch screen display which would show images from the external cameras and text messages sent from the main ship at the surface, or we can call it as mothership. However, neither of these are easily achieved deep down in the sea. For the cameras to pick up anything in the dark depth of the ocean, you need some pretty serious light. That's why Titan had 40,000 lumen of external lighting, which is about 40 times as much as a car headlight. Receiving messages, however, uses a much more elaborated system. The communication and tracking for the Titan sub were both done using what is known as an ultra-short baseline acoustic system. Acoustic pulses could then be used like Morse code to send messages. This is how Titan sub was directed to Titanic on previous voyages, and as it had no navigation system of its own. But that begs a question, how did the surface ship know where Titan sub is actually located? Well, that's where acoustic position system comes into play. First, surface ship would emit a radio frequency from transducer. When the transponder on the Titan received these signals, it would then respond with a similar signal, which would be picked by the surface ship. By measuring the time taken to receive the signal, the surface ship could work out how far the Titan was, and by having multiple transducers on the ship, it could also work out the direction the audio waves come from. By combining these together, it would know where the sub was located and send messages to direct it to the wreck of the Titan. Because we all know the tragic outcome of the Titan voyage, the safety system aboard may seem pointless. And given the corners that were cut when designing the hull, in many ways they were. However, let's see what safety system were aboard that could have helped the passengers if the emergency was different. It is first important to consider that in all possible emergency scenarios where the passenger remain alive, such as power cut or loss of communication, the best option would always be to return to the surface. However, if there was a fire, this would require extra action. This is why there was a fire extinguisher on board and smoke mask for all the passengers, because resurfacing would have been the priority. There were 7 systems aboard to help the Titan to reach the surface. These included powering the electric thrusters, inflating air balloons, and dropping lead weights. However, one of these systems was actually meant as a dead man switch. This means that the tip would have been worked even if everyone aboard has passed out. This dead man switch was made using a material that would dissolve when exposed to salt water. This means that after around 10 hours of diving, the material would completely dissolve and release the sandbags from the bottom of the sub. Because of this lost weight, the sub would have buoyancy and start floating towards the surface. None of these systems would work. However, if the Titan didn't have a fresh supply of breathable air, the key requirement for that is to provide oxygen to the hull and remove carbon dioxide. The oxygen was supplied by onboard tanks and the carbon dioxide was likely removed by a CO2 scrubber. A common choice for this is sodium and calcium hydroxide. These basically trap CO2 in a chemical reaction to ensure that the air is breathable. This tragedy really shows that the ocean must be respected during all the projects within it, from energy exploration to technology innovation. And if it is not, such catastrophe is going to be repeated in the future. Ocean and technology as well, that if it is not controlled in a proper manner, such catastrophe can happen again and again, and such life will be losing every now and then. I hope from all of this you learned something new and found this video interesting. If you did, I really appreciate you to subscribe my channel and like and share this video. And if you want to know how exactly this entire incident happened, you can probably watch this video where I have explained and given a brief gist of the entire incident, which happened over 3-4 days, and the efforts which US and Canada together put in order to rescue the onboarded. Till we meet the next time, another interesting topic, I'll be signing off from here. Thank you so very much.